My name is Terry Clausing. I'm the president and owner of Drysdale Associates Incorporated. We are a small engineering company. We do a variety of things all related to temperature measurement. So for the most part, most of my expertise is involved in measuring how hot things are. Well, there are four basic services that we provide. First of all, we're a professional engineering company, so I'm a licensed PE. We offer a variety of services for ensuring that that the temperature of products and processes is accurate to the customer's specification. In addition to that, we also distribute some equipment. We have a variety of things that we handle. We are also a calibration lab. We calibrate infrared temperature sensors and thermocouple probes. And the last thing that we do is training. We do an extensive amount of training in non-destructive testing. And again, this is training specifically associated with temperature measurement or thermal imaging. It's all about understanding how how heat behaves in different materials. Well, this is really a key question. Most people think that the key to getting accurate temperature measurement is, well, I've got to have a properly calibrated instrument. Okay, but the real key is understanding how heat behaves. So, for example, I have a metal block and a wooden block, and with these two blocks, if I put these in your hand, the most common observation is that, oh, the metal block is cold. Well, actually, the two materials are the same temperature. They've been sitting in this room, for days at a steady state temperature. It's about 19 degrees Celsius. As a matter of science, these have to be the same temperature. But people think this one's cold. Well, the reason for that is that they don't understand what they're sensing. What they're actually sensing is the movement of heat. The metal, because it has a higher rate of thermal conductance, is sucking the heat out of the person's hand, while the wood essentially is more like an insulator. Okay, so the first key to accurate temperature measurement is fundamentally understanding how heat behaves in the materials. Another thing that's very important is understanding how to use the sensors that you're working with. So for example, when you have contact thermocouples, well, most people, they have a contact thermocouple probe. Here's one right here. And they've got a reader, they plug it in, it's reading about room temperature, it must be good. But when you plug it in and check it on a reference standard, like what I have here, you would observe that, oh, well, and I tested this one just a little while ago, it's reading 11 degrees low. Well, that's substantial. I mean, if you're using it for checking your product or your process, that can be the difference between having the proper quality or having reject. It's a big deal. And the error can be either positive or negative. I mean, the thermocouple probe can fail to the high side or it can fail to the low side. The third thing that I'd state that's very important, though, is it's really critical that the equipment be properly calibrated on a regular basis, because that's how you have that peace of mind that your equipment really is reading correctly. It's actually a very common thing. And until you actually test your instrument, you don't know. The failure that people are most aware of would be like this probe, where this one comes in for calibration, but you can see that the thermocouple element is broken. Okay, so this one won't read at all. Well, not reading at all, that's a good thing, because we know this broken and it needs to be repaired. Okay. The other instruments, the fact that they're still reading can give users a false sense of assurance. Okay, I can give you a quick demonstration. We have another probe. And I'll plug it into the reader. And you'll see that it's currently reading about 20 degrees Celsius. Okay? The temperature in this room is about 20 degrees Celsius. So, gee, it looks like, yeah, it must be good. Okay? Now, I have my reference standard set at 100 degrees Celsius. Okay, so I know that this is 100 Celsius. We're up to 130, 137. I believe this is going to max out at about 139 degrees Celsius. Oh, 138. Yeah, it's still coming up a little bit.
It's reading way above 200 degrees Celsius.
Right, it's reading way above, and we'll give you a verification. This is with the NIST traceable thermocouple standard. To verify that the temperature of this plate actually is 100 degrees Celsius. Right. Yeah, so with, if someone didn't know better, they would think that this unit is, yeah, gee, it reads room temperature correct, it must be good. When in fact, it's way off, and it's way off on the high side. So, and you can't tell by looking at it, okay? Well, actually, I can tell by looking at it. The Anritsu products do help to the degree that the user understands how to use them. I'm an engineer. That's both a curse and a blessing. I get a new toy, the first thing I do is I read the instructions, okay? And if I'm going to get a new toy, I read the spec sheet and the instructions before I buy it. So the point is that if you look at the Anritsu catalog, it's more than just a catalog of products. There's a tremendous amount of technical information that's provided that most companies don't give. So for example, I want to point out this section on durability. And in the section on durability, it discusses how many times you can effectively use that thermocouple in different temperature ranges before you're going to essentially wear it out. Well, and then there's also a wide range of styles. Everything about temperature measurement is about having the right tool for the right job. The person that has one temperature probe, oh, they think everything's good. Yeah, they've got one hammer and they can use it to do everything. And it will do everything, but it won't do many things really good. It will drive a nail really well, but it won't drive a screw very well. Okay? This is one of the problems with people that do temperature measurement, is they don't understand the intricacy associated with what you actually have to do to get good, accurate, reliable, and repeatable measurements. I'd say the biggest difference between the Anritsu products and those of Anritsu's competitors really has to do with the company and the customer support that you give. It's about sitting down with the customer, understanding what their requirement is, and speccing the correct instrument for the correct job. You know, I had a particular application a couple of years ago, and I was struggling trying to figure out what exactly I needed. And for this application, my customer was producing a copper pipe that was about 3 inches in diameter, and it's moving continuously. And you know, the temperature was about 400 degrees Celsius. And they really needed to get an accurate temperature measurement of the tube in process as it's moving. Okay, well, this would not be the right instrument to do that with. Well, it covers the right temperature range, but why wouldn't it be the right instrument? Well, it would not contact the surface properly, and it's not designed for the right amount of slip. So, for example, this would be the instrument for making that measurement. You can see the concave surface here, and this instrument is designed specifically for that job. And that's what I mean by, you know, you have to have the right tool for the right job to get an accurate measurement. And Anritsu does a marvelous job of helping the customer select and specify the right tool. Oh, absolutely. Well, so for example, you know, I mentioned to you that we do some infrared work. And with infrared sensors, you always have the issue of what's the right emissivity setting for an infrared sensor. And I do a fair amount of high temperature work with these, generally with companies that are doing forgings. And so for forgings, you know, the most common instrument is an infrared sensor to monitor the temperature of the billets that are coming out. But in order to set the emissivity, you have to know what actually is the temperature of that billet. So this is an Anritsu probe that is designed specifically for that measurement. It has an upper limit of 2,000 degrees Fahrenheit, 1,100 degrees Celsius, and I can use this to get a contact measurement, which I know is going to be very accurate for that billet. And with that, then I can set the emissivity of the infrared instrument to give me, the proper infrared reading. So, I'm entirely reliant on the Anritsu probes in order to get the infrared probes to read correctly. Quality of the products. When we purchase probes from Anritsu, they, of course, they don't have the U.S. National Institute of Standards and Traceability, but they do have the similar function from Japan. So I have certification and test reports from Japan validating the accuracy of the instruments that we use. This is very important to me because as a company and as a calibration lab, we are working on ISO 17025 accreditation for our laboratory and our services. And that accreditation requires that we have traceability to international standards, and without that, we don't have anything. Temperature is critical. Temperature is everything about life. So you really have to have assurance that you know what you are doing in order to produce a quality product. And that doesn't matter what industry you are in, whether you're working with with foods or plastics, glass, metal. Everything is about understanding temperature and understanding how heat behaves in materials. The Anritsu products are very high quality. They have international traceability, and I believe they're a very good value. They are not the lowest price products on the market, but I believe they are the highest value products on the market when you take into account all of the other factors. Well, literally every industry that for which temperature is an important factor, they would benefit from the Anritsu probes. They would. It would not be fair to single out one over another. I do a lot of work in steel and glass, so I could say steel and glass. I mean, they're going to be the biggest beneficiary. But food products, food is critical in getting the proper temperature for foods in the cooking process. Because today, most foods are processed foods. If you don't process it to the right temperature, you end up with bad things that that will make people sick. Well, gee, I mean, is that any less important than having the right metallurgical properties in the steel that's coming out of the mill? It's all very important, and the bottom line is that you really need to have accurate temperature measurements for most everything that you do. It's not about adding more features, it's about specifying the right features for the right application. And Anritsu does a fantastic job working with customers to help do that. The number one thing that I might add is that we offer a service that is fairly unique in the world of temperature calibration. Now, you know that infrared instruments and thermocouples, they all need to be calibrated. But when you take that calibrated instrument out to the line and make measurements, there's, in ISO terms, there's a lot of uncertainty about the accuracy of the measurement that's being made. Well, ISO relies on the calibration of the instrument in order to minimize the uncertainty. In the scope of accreditation that we are working on, we've identified a process for going to the customer sites and essentially calibrating their process to ensure that the temperature of the product or process is within calibration. Now you can see where that's a huge step beyond just making sure that the sensor reads right. This is about ensuring that the temperature of the product is being read correctly. And that's what we do.